Today we're looking at both interior and exterior angles, and what we're doing is we're looking at exterior angles for any sort of polygon, but then we're also looking at interior and exterior angles for polygons that are regular polygons. So we have a series of different formulas to look at here. Let's start off with the general concept. If you were to add up the measures of all of the exterior angles, they always add up to exactly 360, no more, no less. So it's not a formula, it's just something you need to know. So notice that these exterior angles are formed by just taking a side and extending it in one direction, not both directions. One direction, it creates this pinwheel effect. So let's apply that here to example 5. These are the 4 exterior angles. We're going to add them up to 360. All right? So we have x plus 89 plus 2x and plus 85. It doesn't matter how many angles there are. The point is they're on the outside. Those are exterior angles. They add up to 360. So let's combine like terms. X plus 2x is 3x. 89 plus 85 is 194. Let's move the constant terms to the right-hand side. We're subtracting 194 from both sides. So 3x on the left equals 186 on the right, and then we'll divide away the 3. So again, another day where we're using our calculator quite a bit. It does not ask us to substitute the 62 back in. We could if we had to find the measure of those missing angles, but here it just says find the variable, and we did. Now if we have a regular polygon, remember that means all the sides are equal length and all the angles are equal in measure. So think of a square. A square is a really good example. All the angles are the same size. So if we want to find one of those interior angles, we've really found them all because they're all the same size. Or if we want to find one of those exterior angles, we've really found them all because they're all the same size. So what we're doing is we're taking the total number of degrees for the entire polygon and dividing it into equal parts. How many equal parts? Well, that depends on how many angles there are. So if it's the inside angles, it's the n minus 2 times 180 divided into that many equal parts. If it's the outside angles, we'll take the 360 degrees and divide that into equal parts. There's the written description to kind of illustrate what the numerator is representing and the denominator is representing. So let's try this with a nonagon. Here we are, example number 6. This is a polygon with 9 sides, but it's a regular 9-sided figure. So that means all of the angles are the same size. So if they're all the same size, we should be able to find one of them. So here's the idea. I'm going to take all of these words and just condense it down, summarize it as interior angle equals, and then there's a little formula, n minus 2 times 180, all divided by n. So think of that as a useful formula that represents this first box that you see right there. So what that means is we'll take the 9 and we'll drop it in here and here. Here, let's represent this more as a useful formula. I'll put an n right there so that it's just a formula. Now we'll do the calculation. Drop in the 9. So 9 minus 2 times 180, all of that will be divided by 9. There, I got ahead of myself. Let's keep that an n for now. That's what the formula looks like when we substitute the 9 in place of n. And again, you can go right to your calculator. So we want to simplify the top. That gives us 1260. All of that is divided by 9. That means each of those angles is 140 degrees apiece because they're all the same size. What if we wanted one of the exterior angles? Well, that would be that formula right there. 360 degrees divided by n. That's your formula. So 360 divided by 9. Each of those exterior angles is the same size, 40 degrees apiece. What if we have a pentagon? So now we have 5 sides. Let's try this one. We want to figure out the size of one of those interior angles on my regular pentagon. So there's our formula. The interior angle is 5 minus 2 times the 180. We'll take that total number of degrees and divide it into 5 equal parts. My calculator tells me that's 108. What about the exterior angles? So the exterior angle is 360 divided by 5 equal-sized angles. Again, my calculator tells me that's 72. Again, anytime we have a formula, we like to try to work it forwards and backwards. So now that we have used this knowing the number of sides, now we're going to reverse the process. What if we don't know the number of sides? That's what we'll see here in example 7. Here it says find the value of n. So how many sides does it take for our regular polygon to have an interior angle measure of 171 degrees? Remember, each of those angles on the inside, they're all the same size. So if they give us 1, we really know them all. So we can take that information and put it here. Here's our formula right in the box. That's the interior angle that they're giving us. Our job is to solve backwards and figure out the value of n. That will be the variable we're solving for. So the 171 goes here on the left. That equals the n minus 2 times 180 all over n. Now that looks really strange. How are we supposed to solve for n when it's in 2 different spots? Well, let me suggest that you take the left-hand side and turn that into a fraction as well. Now we have a fraction on the left, a fraction on the right. We call that a proportion, and anytime you have a proportion, we can cross multiply. So 171 times n equals, cross multiplying on the other side, there's my n minus 2 times 180. Okay, that's better. Now n is in one spot. Oh wait, there's the other n. How do we combine those terms? They're not quite ready to combine just yet. We want to take this 180 degrees and distribute it to the binomial in front. So the left side stays the same. The right side, we have 180 times n. And 180 times a negative 2, that's a negative 360. Now we have 2 terms, both with the same variable. We want to bring those to the same side. Let's move them to the left-hand side. So I'm subtracting 180n from both sides. And when I do that, on the left-hand side, 171n minus 180n, right, we're subtracting a bigger number. That'll give us a negative result, negative 9n. And that's okay, because both sides are negative, right? Remember that 360, that's a negative. So when we divide both sides by a negative 9 to get n by itself, we'll end up with a positive result. So n will be positive 40. So it would take a 40-sided regular polygon for us to find each interior angle with a measure of 171 degrees. All right, so here's one for you to try. So pause the video, you set it up, work it out just like this, and then continue the video when you're ready to check your answer. All right, here's the answer. Are you ready? There's your first line of work. Set it up as a proportion, cross multiply, and then distribute the 180 on the right-hand side. Move all the terms with n to the left-hand side. And finally, our answer is 20. How'd you do? So that was with an interior angle. So we're going to finish up now with an exterior angle. There on example number 8. Same idea. We want to find n. How many sides does it have? This time it's an exterior angle that they give us. It's still a regular polygon. So go back up to this formula right here. One exterior angle is equal to 360 divided by n. That's what we want to use here. There is the exterior angle they gave us. So that goes on the left-hand side. That equals 360 divided by n. We need to solve for n. So again, create a fraction on both sides so we can cross multiply. So 24 times n equals 1 times 360. Divide both sides by 24 to get the n by itself. 15 sides is what it takes. All right, so once again, pause the video. You try part B, and then we'll check our answer in a minute. All right, are you ready? Here's the setup 45 equals 360 divided by n, and we're going to cross multiply. And then isolate the variable by dividing both sides by 45. So 8 should be your final answer.